Welcome back to AP Chemistry Summer Review Sessions. This is number 6. It is our last one. We're almost done. And we're going to end here on a topic that many of you tend to find a little bit easier than, say, naming. But it's still good to have a refresher on it. And that is how to balance a chemical equation. So pretty basic skill that you're going to be using all year. That when you have an equation, often the very first thing you're going to do is check that that equation is balanced. Because if it's not balanced, you can't work with it mathematically. And later on in the year, we're going to do quite a bit of mathematical work with equations and stoichiometry and moles and liters and ideal gas equation and this, that, and the other thing. And all of those require a balanced equation. Okay, so that's where we're headed. And balancing, I will say, I'm going to show you my method for balancing. If you do some poking around, you might find people that explain it a little bit differently or that have a slightly different method per se for balancing an equation. I don't tend to use actually a specific method. I do what I call trial and error. I just like it better. I think if you once a little bit of practice, you can get good at it, and if you can do it this way, then you actually understand what's going on in that process, which is a little bit better to have you understand it as opposed to simply be able to do it. But realize that if my method isn't working for you or you're still confused, you are welcome to check out another method. I'll reference a few of them in this video as well, or send me a message and I'll be happy to try to explain it to you a little bit different way. Okay, so it'll all work out the same. I mean, if the person is credible and they're teaching you how to balance an equation, you should actually be able to balance the equation when you're done. But there are slightly different ways of getting there. Really, they're all doing the same thing, but a different way of approaching it can sometimes make more sense to you depending on how your brain thinks through the information, okay? And actually, I want to give you a challenge here. Some of you are very mathematically minded. And if that's the case, you enjoy math or you just understand it pretty well, you're pretty good at it, there is a way to balance an equation, by a chemical equation, by turning it into an algebraic equation. And then you're just solving for the variables. So if you make the coefficient, which is what we're trying to find, a variable in algebraic expression, you can develop a method to balance every equation for sure, first time, mathematically. I personally think it's a little bit more work than it's worth, so I don't teach it that way, but I would encourage you to try to figure it out. I have only had 1 or 2 students ever figure this out on their own, and so I'd be curious to see if you can do it, okay? I know that some of you can. You have that kind of brain that you can do that, so if balancing is really easy for you, give that a try. See if you can figure out how to do it without the element of chance to do it mathematically. All right. In the meantime, let's take a look at this, okay? Balancing an equation. So, balancing basics, and I use kind of the illustration of like a balancing beam or a tightrope here, because that's really what it is. You want to balance something to get it to a nice equilibrium, equal point. And the reason we want to do that is actually because of the law that says that, the law of conservation, okay, that you can't create and destroy matter. So if I have this equation right here, and I have aluminum plus oxygen gives aluminum oxide, then you need to make sure that the number of atoms over here equals the number of atoms over here. And the division is that arrow, okay? So the reactants that are on this side here, the number of atoms on the reactant side needs to equal the number of atoms on the product side, the number and the type, okay? And in this case, they are not. So if you look here on this side of my left side of my arrow, if you count the number of aluminum, we only have 1 aluminum. Okay? Over here, remember this subscript means that there's 2 of these. We have 2 aluminum. Okay? That is not balanced. They're not equal. And oxygen is the same. So we have O2 and it is O2, but you're just going to do, I did that wrong. You're just going to do the oxygen atom. There are 2, okay? On this side for oxygen, there are 3. And so we're going to have to make this equal. All right. So the number and type of atoms on the reactant side is equal to the number and type of atoms on the product side. Okay, atoms are not created or destroyed, but except in the case of nuclear physics or in the case of miracles. So, you know, Lord God himself can change this if he wants to, and there are times in the Bible where he did miracles that created things just kind of out of the air there, and the original creation certainly happened by God's word, okay? So he can change this if he wants to, but in general on planet Earth, you can't really change that. You can't just take an atom and make it disappear, and you can't take an atom and make it appear. It has to go somewhere. At the very least, you've got to convert it into energy or something like that. All right, subscripts versus coefficients. This is a big deal. Make sure that you have this straight. Subscript is your little numbers down here. That is a subscript. That's a subscript. That's a subscript. They tell you in a molecule, inside your molecule, how many atoms of that type are inside that molecule. So if we have O2, inside your one O2 molecule, there will be 2 individual oxygen atoms. And please excuse my messy drawings. I'm doing this with a mouse and it doesn't work very well. And then Al2O3, so again we have one big aluminum oxide molecule, and inside that molecule you're going to have 2 aluminums, and I may not be drawing this exactly correct, but we'll say that aluminum is colored in, so there's an aluminum, and then you have 3 oxygen atoms. 1, 2, 3, okay? So all of those are bonded together inside of one molecule. That's a subscript. It tells you the number of atoms inside a molecule. A coefficient is what I call the big number. It's the number in front, and these are going to be here. I haven't put any in yet. If you don't see one, it is understood to be 1, because you have to have at least 1. You know what I'm saying? So this right now is 1 aluminum, 1 oxygen, 1 aluminum oxide, but it's not balanced. And coefficients, coefficients are what you are going to change when you balance. You do not change the subscripts. You could change the subscripts when you're naming a compound, when you're writing out a formula for a compound, but once you have the formulas correctly written, you do not change them. Okay, that is a big deal. Don't change them. All right, so how would I approach this? Well, as you get good at this, I actually just kind of go back and forth, and I would start out here and pick one of them. Typically, I leave elements. You see how this is by itself? Aluminum's all by itself. Oxygen's by itself. Typically, I would leave those alone until last, but in this case, I only have aluminum and oxygen, and both of them are by themselves over here. So I'll just start with aluminum. Why not? You could start with oxygen. I have 1 aluminum over here. I have 2 aluminums over here. Okay, that's not equal. So I know I need at least 2 aluminums here. So I'm going to change that coefficient up front. All right, so now aluminum is balanced. And then check oxygen. I have 2 aluminum here. I have 3 aluminum on the product side. Oxygen. I have 2 oxygen here and 3 oxygen here. All right, how does that balance? Well, that's your rule of 2's and 3's again, all right? The least common multiple is 6. So you want to get them both to 6, okay? So if I have 2 oxygen here, if I put a 3 in front of it, 3 times 2 is 6, so I now have a total of 6 oxygen on this side. And over here, I have 3 oxygen, so I'm going to need to put a 2 in front of it, because 2 times 3 is 6 oxygen. And so what we did is we had an unbalanced equation, and we took and we balanced the aluminum, and then we balanced the oxygen. But if you check again, the fact that we balanced the oxygen means that we unbalanced the aluminum again. And so you actually have to go back and fix that now, okay? Because now I have 2 times 2, 4 aluminum. Over here I only have 2. So cross out that 2 and put a 4. And then go back and double check your work. So I have 4 aluminum here. 2 times 2, I have 4 aluminum here. 3 times 2 is 6 oxygen here. 2 times 3 is 6 oxygen. So I have the correct amounts on both sides, and that is balanced. That's how I balance, just kind of by, I'll just start and kind of go back and forth and back and forth. It's called the trial and error method of making sure they're equal. If that is too much to keep in your head, and the bigger the problem is, the harder that gets to keep in your head, all right? And you really need to have some practice to do it that way. So if that seemed complicated, then try this, all right? I'll tend to make a little grid here, and then list each element on both sides. So the only elements I have are aluminum and oxygen. So here's aluminum. Here is oxygen. Same over here, and line them up, okay? Aluminum, oxygen. I know they've been rearranged, but they are in fact the same elements. And all we need to do now is know how many. And so then write down how many you have. Over here, I have 1 aluminum and I have 2 oxygen. Okay, over here, I have 2 aluminum and 3 oxygen. Okay, cool. Obviously, these are not equal. And so this method just kind of lets you see it better with the numbers there, and it makes sure you don't forget something or like overcompensate or something like that. So this can be a really good method to use, and I'll tend to use this myself when it gets a little bit more complicated. But if you're just starting out, then I'd recommend you use this for a while until you get more comfortable with it. All right. So maybe this time I'll start with oxygen. So I can see here I got 2 on this side, 3 on this side, 2Z's and 3Z's, flip them. All right. So I'm gonna put a 3 here, and whoa, 3 in front of O2. A very big 3. And now, remember, every time you do something up here, you want to change it at the bottom so that it keeps it equivalent as you go. Okay, so I put a 3 here, very messy 3. 3 times 2 is 6. So now instead of 2 oxygen, I have 6 oxygen on this side. So as soon as you change a coefficient, immediately change it at the bottom. And now I have 6 here. Okay, how do I get 6 here? Well, 3, I'm going to need 3 times 2 is equal to 6. So put a 2 there, and that changes both of these because they're both together in one thing. All right, so I changed it to change oxygen, but that also is going to change aluminum. So for aluminum, 2 times 2, I now have 4. For oxygen, 2 times 3, I now have 6. So the good news is we balanced oxygen. The bad news is aluminum is still not balanced. But it should be a really easy fix because aluminum is by itself over here. So if we need 4 aluminum, then it's as simple as putting a coefficient of 4 in front of aluminum, and that's the only thing that changes. So now I have 4, 4, 6, 6. Check. Smiley face. I am balanced. All right. So that was a fairly simple problem. As you know, these can get a little bit more complicated sometimes. So let's take a look at that. All right. Let me give you some tips and tricks first. Again, if you would like to use a slightly different method, that's fine, as long as you are consistently balancing correctly. Okay. And I also would say this, make sure it's not a method that's going to take a very long time. If you had me in regular chemistry last year, one of the methods of doing it is to actually draw out pictures, and that's a very good method and it works very well, and especially if you're a visual learner. But at this point, it would be good for you to get a little bit beyond that, not because it's a bad method, but because it takes a lot of time. And sometimes on tests and things, it might be hard if it's going to take you that long to just balance the equation, because that's often the first step, and then you're going to have to do other things on top of it. For this chapter, it's fine, and it's one of those things that you're going to get quicker at the more you go. So if you need to use that for now, that's totally fine, but I would urge you to try to get away from the picture method a little bit. Okay, so just some tips from me. I put do not change the subscripts, only the coefficients, all right? Big deal. And me personally, I'll tend to start with the most complicated molecule first. I am using a trial and error method, but some of these tips that I'm giving you will help you reduce the amount of time you spend on one problem and can make it a little bit easier for you to solve. So I tend to start with a complicated molecule because that's the molecule that has maybe multiple types of elements in there. And if you change that one molecule, you're changing a lot of things. So it's better to get that squared away right up front and then do the smaller molecules at the end, okay? I leave diatomics and atoms for last. So anything by itself is what I would say. Remember the Hofbrinkels, hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, chlorine are diatomic. There's 2 together, like O2, Br2, something like that. Those are easy to manipulate, okay? If you come down to the end of it and, oh my, bromine is not balanced. Well, if it's by itself, it's easy to do because changing bromine doesn't change anything else. So that's why I say leave it for last. You don't have to, but I tend to find it's easier that way. Don't forget, if this is with big problems, like if this one can catch you sometimes, keep the coefficients in the smallest whole number ratio possible. What does that mean? Okay, so let's say that, you end up with coefficients of 2, 4, 6, 2. I don't know what equation this would be, but those are they. Oh, I'm done, and you check and it balances and woohoo, I'm done with this problem. The issue there is that those are not in the smallest whole number ratio because they all divide by 2. So really it would be better to be 1, 2, 3, 2. 3, 1. But sometimes when you get really involved in balancing, you go above your number. And that's okay. You can, if it balances 1, 2, 3, 1, it also balances 2, 4, 6, 2. Okay, that they both mathematically balance. We just like to put it in the smallest whole number ratio. So do a quick check at the end. Make sure they're not, usually it's 2 or 3 that they're divisible by, and then you can just reduce it down. So that's a pretty easy fix. You just got to catch it. Okay, pencils and erasers are your friends, or something you can erase. So I like to do these ones in pencil or on a whiteboard or something that you can erase or scratch it off to the side before you write it in. If you do them in pen, sometimes they can get a little messy. Okay, and then tip from me, start with the element that is only in one substance on both sides. So things that are going to be hard to balance are problems where something shows up in more than one place. So for instance, if you have oxygen, and on this side of the equation, oxygen is only in one molecule, maybe an SO4 or something like that, but on the other side of the equation, you have SO2 and then like H2O, so that O is now in 2 places. That can get tricky to balance because changing like one thing, now you have 2 things. Like it just gives you more options for trying to get it to balance, but there's only one right option, so it can be a little bit tricky that way. All right. So I would start with the element that's only in one substance. So in other words, carbon is in one substance here, and it's in one substance here. So I might start with that one. Okay. Oh, let's see. Why is this not? There we go. All right, monster time. So most of you probably are fairly familiar with this, so I just wanted to give you a hard one to kind of get you going. If you can solve the hard one, then more than likely you can solve the easier one. So that's why I do this. I do, if you haven't had me before, I call them monsters. Monsters are hard problems that are just big and complicated and difficult to solve, but I always like to encourage my students that if you're a hero in a book or a hero in a movie or something like that, and you are, Mr. Knight or someone with a big sword, and you're out on this quest or adventure, and a monster comes along. Nobody likes the hero that runs away from the monster, right? Are you really a hero if you run away? So when you see monsters in chemistry, don't run away either, and don't turn into a coward and run and hide, and I can't do this, oh my goodness, this is too hard. When you see a monster, you fight it bravely, okay? Maybe you won't quite slay the monster. That's okay. You can still be a hero if you don't quite slay the monster, but you're only a hero if you try. So in chemistry, try, okay? They look monstrous and scary and staring you in the face. A lot of times once you get going, you'll see the way to solve it. It's more of a mental thing to kind of break through that barrier of, oh no, this is scary, and be able to actually solve it. So let's give this a try, okay? All right, oh boy. Okay. So, we'll draw a little thing. And this, I can tell you right now, this is monstrous. And here's why. This is what I was talking about. See on this side, we have SHNO. And so, of course, we'd only have those on the other side. But the problem is that that O on that right side, on this product side, is in 3 places. That's tricky because every time you change anything, you're changing O, but O is only in one spot over here. That can really make these kind of things a very tricky thing to solve. So SHNO, we actually have 4 elements, but they are broken up quite a bit. And so I'll put them over here as well. SHNO. Let me see, where do I start this? Let's just write down our numbers. What do we have here? S, we only have 1, we have 1 H, we have 1 N, we have 3 O's. Okay? Over here, we have one S. That does look like it's it. H's, I have two H's here and another two here, so that would be 4 H's. N, I only have one N. And then oxygen, be careful in this one because it's in 3 places, okay? So 4 plus 2 is 6 plus 1 is 7. All right, so clearly we are not balanced. Now, S is already balanced. N that's by itself here, I'm actually just going to leave S alone. It's already balanced, it's by itself, I can fix it later if I need to. Hydrogen is not balanced, nitrogen actually is, and oxygen is not. So you want to do either hydrogen or oxygen. Problem is, on this side, hydrogen and nitrogen and oxygen are all combined as one thing. So whatever I do here, I've got to change this one. All right, so I'm going to start there. Let's just start with hydrogen. I need 4 hydrogen over here. So let me start by putting a 4 here. I need to change these numbers. I'm going to try to write small. So 4 there. Okay, and immediately change it down here. So now I have 4 hydrogen, and I have 4 nitrogen, and I have 12. Whoop, that's a 12. Okay, that's a 12. And I have 12 oxygen. Great, so I balanced my hydrogen, but nitrogen is now unbalanced, oxygen is still unbalanced. So let's fix nitrogen, okay? So if I have 4 nitrogen here, I need to have 4 here, so I'm going to put a 4, because there's only 1 nitrogen in front of this one, and this nitrogen becomes a 4. Oxygen changes, don't forget this is not my only oxygen, check here and here. So I have 4 plus 8, 4 times 2 is 8, so that would be 12, and one more is actually 13. Is that right? Yeah. Right, okay. So now I have 13, okay? So we're actually really close right now. That oxygen is still unbalanced. And again, the only way for me to touch oxygen on this reactant side is this number here. And I know that whatever I do to this big guy, because of that nitrogen, there's only 1 and 1. Whatever number I put here, I'm going to have to put here. So in these cases, I sometimes just keep going up and just see what I get. So let's try a 5. I have a feeling a 5 is not going to do it because it's going to be 15. And we'll give it a try. So put a 5 here. Which also, because of the nitrogen being in a 1-to-1 ratio, if I put a 5 there, I have to put a 5 here. And let's just fix that. Okay, so now I have 5 H's. Now I have 5 N's. And these, I mean, this is a monster, okay? These can get a little big sometimes. Now I have 15 O2. Over here, still 1 S. Hydrogen, I haven't touched hydrogen yet, actually. So that's still 4. Nitrogen is now 5. Oxygen, 4 and 10 is 14, is now 15. Okay. Problem is, we're really close again, and there's just one thing wrong, and that's hydrogen. Hydrogen's not working. Again, problem is, if I want to change hydrogen, I have to change this one. So I'm just going to keep going up. Let's try a 6, which means I also need a 6 here. See what happens, all right? Still 1 S. Now we have 6 H's. Now we have 6 N's. 6 times 3, now we have 18 O2's. Over here, 1 S. Still only 4 hydrogen. This is going to be a 6 on my N's, and then oxygen 4 plus 12 is 16, and now we have 17. Ooh! Okay, we are close, but we need 2 more H's, and we need 1 more O, right? We need 2 H's and an O. Hey, does that sound familiar? Yeah, that's the formula for water over here. So that's kind of cool. So let's go ahead and add another water. We have 1. Let's make this a 2 and see what happens. So 2 times 2 is 4, plus these 2 over here, it's going to be 6 hydrogen. And oxygen, we added another one, so we now have 18 oxygen. Did that do it? 116666 1818. Yes. Okay, so that would be how I would solve that. And now that is what I would call a monster. Okay, that took me a while. It wasn't obvious to me what the solution was right away. I had to do some back and forth and this and that. But even a monster, you can solve a monster. Just give it a little bit of time. And usually I don't give you monsters. Just gotta give you a few, right? Okay. All right, so our final answers here, this would be 1, 6, 1, 6, 2. All right. Hopefully that made some sense to you. So that is actually it. I do have some more, not that, no, come on. Practice for you. And this PowerPoint is available to you on our Google Doc online. So if you get into that, you'll see the whole PowerPoint. I do have some more practice problems that you can go through and try, okay? And I really would recommend trying these. There's more practice out there as well. So like this is another pretty big one. Let me just give you a couple tips here with this one. When I do a problem that has carbon in it, see how there's carbon here? And I know that looks huge and scary, right? Like this might be another monster. When you get solving it, it probably won't be as hard as the other one. Here's why. This molecule, sometimes when they're that big, it's actually easier. Because like, you don't have that many options. You've got to change the big guy. I almost always start with carbon here. Let's actually just solve this one, okay? How would I solve this? I start with carbon. So you see how I have 5 carbon here? On my product side, carbon, is often only in one place. So I know I have to have a 5 carbon here. Okay, because that's my only source of carbon on both sides. If you have carbon in your problem, I would suggest starting with carbon. It doesn't always work, but it tends to make it easier to solve. And then let's check. We have 6 H's. We only have 2 H's over here. So I'm going to go ahead and put 3 times 2 is 6, right? So I'm going to put a 3 here. Okay, my H's are balanced. I have 2 nitrogen here. 2 nitrogen, that's balanced. 1 plus 2, we have 3 oxygen, we have 3, 4, 5 oxygen, but actually oxygen's by itself, so it's pretty easy to fix. So I have 3, 4, 5, just put a 2 here, right? So that's 4, 5, 1 sulfur, 1 sulfur. I think we're actually balanced. 5, 5, oh no, I forgot these O2s here, hold on. 5 carbon, 6 hydrogen, 2 nitrogen. No, I forgot oxygen here. So we have 10 plus 3, 13, and 2. This is 15 oxygen. Okay, so we have 1 here. We're going to need 14 here, so that would be a 7. Okay, so 7 times 2 is 14, plus 1 is 15. That should be balanced. So sometimes they look really big, but if you'll keep a few tips and tricks in mind, they're not that bad to solve. One other last one, and if you want me to explain this more, just feel free to message me or something. It's what I call double or nothing. Sometimes you'll hit a problem, and you'll have, let's say, it often is oxygen actually, and like over here, oxygen only comes in 2, so maybe you have like an NO2. Okay, over here on the product side, oxygen only comes in 3s. Maybe you have an NO3. And these can get a little tricky because it seems like no matter what you do, like the one side's going to be odd and the one side's even. And so you do all this work and you get everything balanced and everything works except one thing. And that one thing does not work because on the reactant side there's an even number, on the product side there's an odd number. So what I do in that case is I just say double or nothing. I will double everything except for the problem child or the one that's not working. So I double everything except the oxygen, and then at the end check out the oxygen, and that usually will work because, you know, 2 odds make an even. So again, it is actually mathematically based, but there's some tricks to help you out. Alright, that was quick, but just a refresher and some, you know, things to not forget to do and tips and tricks and that sort of thing. You should have all the info you need at this point in time to be ready for AP Chem when you come back in the fall. Please ask me questions. I do not mind. You received an email with communication from me, so feel free to get in contact with me if you have any questions at all. Alright, looking forward to seeing you then. Have a good summer.